Hi, we are the Brain Trains, and we did our project over traffic safety measures for railroad crossing and how railroads affect nearby intersections. So here's some statistics regarding train car accidents in the U.S. There are approximately 5,800 every single year according to the U.S. DOT, and in that 5,800 there are 600 deaths and over 2,300 injuries. And some people might just ask, why doesn't the train just stop when they see a car in the railroad? And that's because the average freight train, moving at 55 miles per hour, takes over a mile to stop. And you'll see in the next videos here some examples actually of real life train crashes. There are two general types: getting struck by because they're stuck, and getting struck by because they're almost trying to beat the train. So obviously you see the huge risks that these sorts of intersections pose through those videos, and how engineers try and mitigate those risks are through traffic control devices. And there are two main types of TCDs when it comes to railroad crossings, and that's active and passive devices. When you get into active devices, those are your flashing lights, your cantilever arm that drops down, and your automatic gate. And those are to prevent people from crossing the track. And how these are triggered are through sensors that are set distance away in the highway in the railroad, which I'll mention a little bit in the next slide. But those are three types of TCD active devices. And when you get to passive devices, these tend to be a lot more riskier for the average driver. These are your crosswalk signs, which are just simply a sign. And if a train doesn't blow their horn because they're in a quiet zone, or the driver just simply doesn't see the train coming because there are no lights, they could be in huge danger for a potential fatal accident. So these traffic control devices that we just mentioned have the impact of changes in intersection phases out of railroads. So they're affecting all nearby intersections, and there are 5 factors in changes in intersection phases. The first one is joint agency coordination, which is the coordination between the railroad company and the DOT. Second one is extended advance warning times, which, as I mentioned before, sets the limit of when those drop down gates and cantilever arms are going to come down, and usually it's more than 45 seconds before the train arrives at that railroad crossing. The third is second train circuity at multiple crossing times, and this detects a second train and makes the proper adjustments on the tracks to avoid a collision, which could be catastrophic to both parties. The fourth one is diagonal railroad crossing, both highway approaches to the intersection. A bit of a mouthful, but this occurs when railroads run diagonally to the highway. And why this is important is that with a diagonal crossing, you're not dealing with necessarily one intersection, you're dealing with two. And how these can be ran kind of varies, and it can be broken down into two systems or one system to make sure the vehicles on both sides of the road are cleared out prior to the train crossing that. The last one is the pre-signals, which are responsible for controlling traffic that is approaching the highway rail grade, crossing towards a nearby highway intersection, and it operates as part of the highway intersection traffic signal system. You're probably asking yourself after you hear all this information, what are the rules and sort of regulations and policies when it comes to these sorts of things in order to mitigate and limit the amount of people that are losing their lives or getting injured in these. So these are all stated in the Railroad Highway Grade Crossing Handbook. And what's wrong with this is that they have some shortcomings on a couple different topics. And that one of our examples is that the handbook includes high-speed trains as a factor, but doesn't include conditions for what is considered a high-speed train, such as a minimum speed. Another example is that the handbook often uses past collision history as a factor for upgrading railroad crossings from passive to active traffic control devices, but it doesn't state specific conditions for what past collision history means. So there are a lot of broad things that are mentioned in this manual that don't really have any real life implication or can't really be measured. And they also formulate the calculating of the likelihood of the condition, but their use is far from universal, and it can vary depending on the sort of location that's in, and that's where this sort of system falls short. So getting to our takeaway slide here, and that's important improvements must be made to existing regulations and policies. There is just simply too many broad policies in place, and there needs to be a set standard. To keep yourself safe, always pay attention to regulations and safety measures regarding railroad crossing. And trains affect not only grade crossing traffic control devices, but also the intersections near them. Thank you.